Hello, my name is Karen. I am a software developer at Marple since about 3 years. And today I will do a demo of how to use Marple DB SDK. So what I will do is I will start with some files, push those to Marple DB using the SDK. And then once our data is in Marple DB, it's nice because no matter the file type it started from, it will all be in one structured, nice way and accessible to a lot of tools that are out there. For example, Marple Insight. But for this case, we will connect Marple DB with MATLAB and do some deeper analysis there. The case we are looking into is a wing deflection test on Airbus aircraft types. And more specifically, we are looking into 3 aircraft types, the A319, A320 and A321. So I have gathered some data, and 2 of my 3 aircraft types use a logger that streams the data into an H5 file, and the 3rd type creates a CSV file with the data. So that means that already to start from, the data is in 2 different file formats, which is no problem at all. Once we have the data in Marple DB, the case that we want to look into is the damping ratio of the wings. So let's get started. We are looking at this point at Marple DB, and you see here 2 data streams. The data stream is a way to flow data from files into Marple DB. As I mentioned, there are 2 aircraft types that have loggers logging into H5 files. Those datasets have already been added here. I already prepared that. You can see I have some datasets lined up here. And we also have a 3rd type which logs into CSV files. Those we still have to fill into Marple DB, and this I will do now using our Python SDK. First thing to mention is that the loggers log into a different file type, but also they use different signal names. That is actually not a problem, because in Marple DB you can fill in what we call a signal alias. And this way you make sure that there is one signal with like a unified name in all of your datasets, which you then can use to do all other things on your dataset afterwards. So we want to look into the wing deflection. So we need the wingtip placement in all of our files. In the first loggers, this is called wingtip placement, and in the CSV logger, this is called differently. So let's quickly set up a signal alias here. The alias I want is wingtip placement, and in our CSV logger, this is called string. So now, if the data comes into Marple DB, there will always be one signal called wingtip placement. Now I will use our Python SDK. For this, I can simply create an API token here and then connect to it. Here you can see my Python script. This is quite simple. From Marple import DB, so we are talking to the DB SDK, filling in our API token and URL, and then I say stream to this name that we already saw before, and then we will loop over all the files in a folder that I prepared, add some metadata, and then we're good to go. So let's run this thing. Let's go. Okay, perfect. If I go back to DB, you see that indeed 10 datasets have arrived. Some are still waiting to be imported. This goes quite quickly. Normally, Marple always ingests quickly, but normally we use much bigger files. For this demo, it's quite like this. So let's see a quick sanity check in Marple Insight. You can see that indeed the data is present, the ingestion worked fine, so all is well. Move on to the second part, where I will use MATLAB to connect to this data in DB. There's a lot of documentation about the MATLAB SDK on our website. The most important thing to know for now is that it's packed as a db.m file, and I've already imported this into my MATLAB setup. I have configured everything to Marple DB as like the API token and so on in this config.json file, and then I can use it into my MATLAB script and directly get all the data I need from all my different file types. So let's get into it. Here I list the streams I want to include in my tests. And I collect all the datasets for all those streams. And then for every dataset, we will calculate the damping ratio of the wing. So this is actually where the magic happens. Here we connect to the Marple DB SDK and get the data for the wingtip placement. Remember the signal we just made sure we have in all our datasets. Then we will use this in our calculation, store it, and in the end make a nice box plot out of it to look into the damping ratio of all our tests. So now we have put it all together. Let's run this script. See, the datasets are being processed, and in the end, indeed, we get a nice box plot, and we can see, for example, the A320 has a much bigger variation on the damping ratio. One thing to mention, we fetched this data from Marple DB, but it's also stored in a local cache on your laptop, like you can see here. And this is nice because now probably I want to dive more into the data. I don't have to fetch it again. I can just use it from my local cache and continue my investigation. So that's about it, what I wanted to show you. Thanks for watching.